This video is on the objective add or subtract vectors. So, this is the instruction you'll see, but here's the question. If you want to see more about the topic, click on more instruction. Look at their videos, their notes, their examples, and hopefully those help you. I wanted to show you though, for being the first video, some instructions so I don't have to write things down. So performing vector addition and subtraction. So now that we've gone over in the last assignment, properties of vectors, we can perform operations involving them. While it is convenient to think of a vector u in the component form with the wedges, right, as a position vector, x comma y, it's convenient to think of this as an arrow or a directed line segment from the origin to a point xy. But vectors can be situated anywhere in the plane, right? You don't have to start from the origin, as you saw in the last assignment. Right? They can start from anywhere. It's just, when they start from the origin, they're called position vectors, standard vectors. The sum of two vectors u and v, or vector addition, produces a third vector, which will be called u plus v. And this new vector that's created by adding two other vectors is called the resultant vector, right? The vector that results from addition. To find u plus v, we first draw the vector u. And from the terminal end of u, we draw the vector v. So it's like adding vector v onto the end of vector u. It's really that simple. In other words, we have the initial point of v meet the terminal end of u. This position corresponds to the notion that we move along the first vector, and then, from its terminal point, we move along the second vector. The sum u plus v is resultant vector because it results from addition or subtraction of two vectors. The resultant vector travels directly from the beginning of u to the end of v in a straight line path, as shown in the figure below. Alright, now you might also do the parallelogram method to see what u plus v and u minus v are. And I'll actually draw some of this stuff up here. Just know too that minus v, when you put a minus sign in front of a vector, just reverses the direction of that vector. So it'll have the same length, just the opposite direction. Alright, so let me show you these diagrams myself. Right? So if I had a vector u, so say here's the initial point of u, and arrow, here's the terminal point, and say this is vector u. Now, say I would like to add on to this vector v, right? So here's I traveled from initial point of view to the terminal point of view, and then I want to add to this motion vector v. Now say vector v points in this direction. So say there's vector v. Alright, well then u plus v. Alright, u plus v is this vector here. They're basically describing, going along u and then adding v is essentially doing this. Starting here and ending there. So starting at the initial point of u, ending at the terminal point of v. This pink vector I just drew is the vector u plus v. All right. Now, if you want u minus v, right, u minus v is just u plus negative v, right? And as I mentioned, negative v, or the opposite of a vector, is just the same vector but pointing in the opposite direction. So if I want, here's u again, But now say I want to add on negative v. Well, that's the same as vector v, the same length, but pointing in the opposite direction. So like this. There's negative v. Now again, these are hand drawings, so that might not actually be the exact same length. I apologize. And then the vector u minus v would be this vector here. Here's u plus minus v. So this vector here, this resultant vector, is u plus negative v, or u minus v. Right. Now, this u minus v ends up being the same motion, the same vector, as the other diagonal of a parallelogram you can create with u and v. So here's u, here's v, and then say over here I put v again, right? So the same vector but over here. So it should be parallel. They should be pointing in the same exact direction. Here's v again, and then I finish the parallelogram with another vector u. Here's vector u. I draw a vector u again up here. There's u, and do you see the parallelogram being formed here? This side is parallel to this side, because they're both the vector u, and this side is parallel to this side, right? They're both vector v, so we have a little, parallelogram using vectors u and v. And then you see that one diagonal going from the beginning of u to the end of v forms the vector u plus v. And the other diagonal going from the end of v up here down to the end of u down here, the other diagonal, do you see how that's the exact same vector as u minus v was down here? These are the same arrow, but pointing in the same direction, just written in different places. So the other diagonal is u minus v. Okay. All right. So you could actually get u plus v and u minus v drawn in the same, parallelogram. All right, just get rid of these two vectors that I'm covering with my hand down here. Okay. One diagonal, the other diagonal. All right. So that's what they're talking about here in these diagrams. All right, and then they have an example, but I'll leave the example reading to you. All right, so let's go back to the problem. All right, so here we're given the vectors u and v shown below. Now these are just pictures. They don't even give us components. All right, we'll talk about adding components of vectors in another video. So we're given the vectors u and v shown below. Here's vector u, and move it around. And I can move it all over the place. Here's a vector v, right, and move that around. There. And if you want to reverse the vectors, you just toggle these, right? There's, see how minus v now points in the opposite direction. Then I switch it back, points in the opposite direction. So, given the vectors u and v shown below, find u plus v. So it says, submit your answer by dragging the endpoints of the blue vector to the desired locations. You may reverse or flip orientation of the vectors u and v as necessary. Alright, so if I want to do u plus v, remember how that works. So I'll just have the end of u point to v there, like that. So here's vector u, and then from the end of vector u I have vector v. So u plus v, I'm going to have the beginning of u plus v start at u, right there. And then the end of u plus v, go back here. There you go. That's all they want. And if they wanted u minus v, I'd just put minus v up and draw a picture basically on the computer here that I was drawing on paper. Wonderful. Alright, so a little interactive problem there. Alright, so pretty simple. Now if you want to add component-wise, alright, going back here, see how easy it is to add vectors and subtract vectors when they're in components, when they're in the wedge forms like this? So like this example here, say u has components 3, -2, v has components -1 and 4. The new vector u plus v, well, to add vectors, you just add the components. Add the corresponding components. So u plus v has first component 3 plus -1, right, adding the first components. And u plus v has second component -2 plus 4, adding the second components. And you do the same exact thing for subtraction. Just take 3 minus -1, which would be 3 plus 1 for the first component of u minus v, and -2 minus 4, right, which would be -2 plus -4, same thing for the second component. So yeah, adding and subtracting components is very simple, and they got some videos and stuff. Again, I'm not going to show you all of that. Right? Great. So hopefully, watching me go over this, draw some pictures, looking at the more instruction if you need to, reading the answer explanations when they come up. Hoping all this stuff helps you out when you're working on these kinds of problems on your own. And thank you very much for watching.